to the ice. Patrick Harlow goes.
Everybody, that was a pretty good video showcasing Newton's 3 laws of motion. So in this video, we're going to talk about the 3 laws of motion, and you can see the 3 laws of motion, everything that we see, that regardless if they're motion or not, because that's what Newton came up with in his 3 laws of motion. But in that previous video of the hockey body checking, that is a great example of how things move and not move, etc. So just to give you a little bit of information about Newton is that, you know, he's a Christmas baby, and he didn't grow up in such a fantastic house or family life. His mother sort of went away with another guy, sort of just left Newton by himself, and Newton sort of resented that. Why his 3 laws of motion is so incredible is that, you know, when we're sitting here, when we're just thinking, we don't really think about, how is there a law or other laws sort of dictating how things move or anything like that? Well, Newton actually came up with these and discovered these 3 laws as he was kind of observing, you know, things moving. And why it's pretty cool is that all these laws, regardless if we're looking at small little cars moving, big cars, you know, NASCARs, Formula Ones that's going really fast, or planes or ship, you know, those ones are still following the same rules of motion as something in space. And we're going to look at these 3 different laws. So the first law is sometimes called the inertia law. The 2 different parts is that if things are in motion, it will continue in motion until something acts on it. Or another one, the second part of it, I sort of jumped ahead, is that an object that is at rest will stay at rest until an unbalanced force acts on it. So let's think about what this means. That means that, well, I'm just sitting here, no one's gonna move me until something pushes me over or pulls me, until another force acts on me. So that's sort of the inertia law. So if you're not gonna move, you're not gonna move. So then the second part of the first law is saying then, well, what about if something is in motion? If, you know, if you're throwing a football or baseball. Well, if you're throwing a baseball or football, or if you're just kind of throwing a pen across, well, it will still keep going until something acts on it. So on Earth, you know, when we see it, when we throw a pen or ball, it actually sort of, you know, it dives down and then eventually it stops. Well, because there are other forces that's governing this pen aside from my applied force or my force throwing this pen. That means that there's gravity, you know, there's air resistance and all that, that's sort of slowing it down. But if we were to think about if we toss this in space, well, there's no air there and gravity is very minimal. Well, it's going to continue and continue until something actually acts on it. Either it hits something or another gravitational field from another planet pulls it, but it will continue to go straight forward. So how do we see this in real life? Well, if we look at the video of the hockey player getting hit, basically, you know, the hockey player is skating and somebody hits him. Well, the hockey player is in motion, and it is acted upon by another person. So then the hockey player moving is still going to keep going in motion until, you know, the other force acts on it. How that works is that if the hockey player, you know, skating and then he gets hip checked from that means hitting from the below. Well, the top part is still in motion, so it's still going to move forward. I don't know if that truly make any sense, but that is also why, if you look at this video of the crash test dummies, you know, that's why we need to wear seatbelts. If we're driving a car, even though when we're driving a car, we don't feel like we're moving really, really fast, but we are. And suddenly if the car were to hit something, and if you're not wearing a seatbelt, well, look what happens. So you can see in this video, this is a crash test dummy testing, you know, the effects of wearing a seatbelt and not. And you can see that this one in particular is not wearing a seatbelt, and you can see that the body is in motion, but the head, because the top part is not sort of secured, the top head part is still in motion. So once it collides with something, the head is still in motion, so then if it goes fast enough, the whole body could be propelled out and through the windshield. That's why it's really important to wear your seatbelt. So that's Newton's first law. Hey, so have you ever been on a romantic date with your boyfriend or girlfriend? They might actually have a pretty nifty trick to show you, and that's pulling the tablecloth without pulling anything else. Well, this is a BMW commercial showcasing their motorcycle that is doing the same trick, but for a lot bigger dining table. So what this is actually Newton's first law, because everything that is sitting on the table has inertia. That means it doesn't want to move. The plates, the candle setting, the glasses, everything, they all have inertia. They're just going to sit there. They're not moving. So what happens is that when you pull the tablecloth, you're pulling underneath it, but since everything is sitting on top of it is still staying still, well, it's going to just stay still. So that is a very good example of Newton's first law of inertia. And one thing about inertia is larger masses would have larger inertia. So if you want to try this out, take a tablecloth, take a piece of paper, put different objects on the paper and try to rip the tablecloth out without, pulling things out. Obviously, you don't want to break anything, but be careful with this. And you'll notice that heavier objects is easier to do this trick on because they have a lot more inertia. They'll stay still, while smaller, lighter objects will have less inertia and they'll sort of get pulled with the cloth. So that's Newton's first law. Hopefully that helped you understand it a little bit better. Even though when you read it, it's like, oh yeah, it makes sense, but try to understand it, and hopefully this help has helped you. So see you later.